Title of the first section today is Solving by Elimination. In this question, we'll solve two equations, but we'll solve using elimination, where we'll cancel a variable out. First equation is 2x minus 3y equals 11. Second equation is 2x plus 2y equals 6. To solve using elimination, we can either add or subtract these equations together in order to cancel a variable out. For example, if you look at the x's, they both have the same coefficients, 2x and 2x. If we subtract 2x minus 2x, that would cancel the x variable out. We'll put parentheses around the second equation to remind us that we're subtracting each term in that equation. So 2x minus 2x would cancel. Negative 3y minus 2y would be negative 5y. And 11 minus 6 would be 5. Solving, we can divide by negative 5, and y equals negative 1. To get the second part of the solution, we can take negative 1 for a y value, plug it into either equation, and that will solve for x. If we take the first equation, 2x minus 3y, but instead of y, we can substitute a negative 1, equals 11. Solving, we have 2x, negative 3 times negative 1 is positive 3, equals 11. Subtracting 3 on both sides, 11 minus 3 would be 8, and dividing by 2, we'll have x equals 4. X equals 4, y equals negative 1, and again you can write that as a point, x comma y, which is 4 comma negative 1. Which also means if you graph the two equations on the xy axis, they will cross at 4, negative 1. Next section notes is titled More Elimination Questions. First question and only question for the section is negative 3x plus 7y equals 14. And second equation, 5x plus 2y equals 45. In this question again, we want to add or subtract so we can cancel the x's or y's and solve for the variables. In this question, the coefficients do not match up, so at the beginning we cannot add or subtract. What we need to do is multiply by some numbers so the x's have the same coefficient or the y's have the same coefficient. For example, we can take the first equation and we can multiply by 5, and we can also take the second equation and multiply by 3. This way the first equation, the x's will be 15x, and the second equation will also be 15x. Multiplying the first equation, the 5 will be distributed to each number, each variable, and every term. So 5 times a negative 3x is negative 15x. 5 times 7y, 35y. And 5 times 14 would be 70. Second equation, 3, again times each number and each term, be 15x. 3 times 2y would be 6y, and 3 times 45 would be 135. From here, the x's have the same coefficient, 15. It's okay if they're different signs. What we can do with negative 15 and positive 15 is we can add these two equations together, because negative 15 plus 15 would be 0, or the x's would cancel out. And 35 plus 6y would be 41y, and 70 plus 135 would be 205. Solving from here, we can divide by 41, and y equals 41 goes in evenly to 205, goes in 5 times, so y equals 5. To get our second variable, again, once we have y equals 5, we can use either equation that we started with and plug in y equals 5. You can also use the equations that we multiplied by. If we use the very first equation, negative 3x plus 7y, but we'll substitute a 5 in for the y, and equals 14. Simplifying, we have negative 3x plus 35 equals 14. Subtracting 35 on both sides, negative 3x equals negative 21, divide by negative 3, and x equals 7. So our two answers, x equals 7 and y equals 5. And again, we can write that as a point x comma 5, x comma y, which is 7 comma 5, which again is the point that these two lines would cross on a xy graph. Title of the last section today is No Solution and Infinite Solution. Problems. In this section, we'll continue to use elimination, but instead of answers, we'll either have no solution or infinite solution. First question is 2x plus y equals 5. And second question, 2x plus y equals 6. To solve this question using elimination, if we have 2x and 2x, we can subtract those to cancel out the x's. So 2x minus 2x would cancel. Y minus y would also cancel or be 0. And 5 minus 6 would be negative 1. In this case, the x's and the y's canceled out, and we're left with just numbers. In this case, we have 0 equals negative 1, which is a false statement. If the variables cancel out and you're left with a false statement, the answer would be no solution. The reason this graph or these equations are no solution, if you did graph these, there would be parallel lines that do not cross. If they do not cross, we cannot get a solution using elimination or substitution. Second question and last question for the section. 2x plus y equals 3. And second equation, 6x plus 3y equals 9. Again, solving by elimination. On this one, we'd have to multiply first, since the x's do not match up and the y's do not match up. So if we multiply the first equation by 3, we can multiply by 3 so the x's would match up. 3 times 2 would be 6x. 3 times y would be 3y. And 3 times 3 would be 9. When we multiply the first equation by 3 and compare it to the second equation, both equations are exactly the same. If you continue the elimination process, subtracting, the x's would cancel, the y's would cancel, and the 9's would cancel. So we'd be left with 0 equals 0. Similar to the other question, if all the variables cancel out, but you're left with a true statement, 0 is equal to 0, the answer would be infinite solutions. Infinite solutions means there's many points or many solutions for these equations. In terms of a graph, this would be a line on top of that same line. If you take any point on the line, it also works for the other line.